but I will. Oh, what grade is he in?
He's in 9th grade.
9th grade. Are you really close with your brother?
Kind of.
Kind of, sorta. That's super cool that he helps. That's really good. Okay, homework and test manager. Changing dimensions. Here we go. Okay, so I think what is tricky is just knowing what to do on this one. You're a beastie kitty. Beastie kitty. Okay. You fight a lot? Yeah. I did with my sister. I still do. Never goes away, but that's okay. You know. All right. So first question that you end up getting is finding the area of the geometric figure there. Okay. So what do we do to find the area? How do we find the area of a rectangle? What's our formula? Yeah, length times width. So we would go length times width. So 8.8 times 11.5. Very good, yeah. So whatever that is, that's what you would type in there. So the first one's just an area formula. So not too bad there. Okay, the second one is one of those vocab things. And remember, if you guys don't know the word, that's okay. You can guess. Yep, they are similar, but you can guess. And it says final check. Oh, it's wrong. Darn it. Just hit try again. And it flashes the answer real quick. Did you guys see that? I'll do it again just in case. So I still guessed. Watch, I'm going to hit try again. Bam, it flashed it. Did you see it? It's similar. Similar figures. So then what you would do is you would take a minute and get it into your memory and say, okay, similar figures have the same shape, but not necessarily the same size. It's a way to help you learn the vocab. That's it. Or you could Google those words, you know, or look back in the videos or the Moodle stuff because it's there. Okay, find the scale factor and ratio of the perimeters for a pair of similar trapezoids with areas 49 centimeters squared and 4 centimeters. So they gave us an area ratio, okay? So they want that, they're saying there are two similar trapezoids. One of them has a bigger area, so you can kind of, you know, just to get it in your brain, and one has a super small area. And they're comparing them by making a ratio. So they're saying the ratio of the areas is every 49 square centimeters of the first one is compared to 4 squared centimeters of the second one. If I want to change that down to a scale factor or a perimeter ratio, okay, so I'm saying I'm comparing the areas. Now I want to scale it down to just compare the sides and the perimeter, and they're the same thing. All I have to do, does anybody remember from last week? What do you do with the ratio, with each of the numbers in the ratio? It's kind of like we're working backwards, and areas are things that are squared. So what's working backwards from things that are squared? It's really close to that, Isaiah. It's not dividing, although that's a really good guess. It's, yes, good job, Isaiah. It's the square root. Yeah, the square root. So we're going to take the square root of 49 and the square root of 4. That helps us work backwards to get the ratio of, so this would be a scale factor. These are how the sides compare. So every 7 centimeter side is compared to 2 centimeters in the smaller one. or perimeter. But either way, the ratios break down. So like we might get bigger perimeters, but they would simplify to be 7 over 2. That's what this is saying. So the scale factor would be 7 over 2. And then the ratio of the perimeters is exactly the same way. 7 over 2. Yay, we're so smart. Does that make sense, guys? So if they give you areas, square root to get the sides or the perimeter. Okay. So now, this one's kind of similar to that, but they're not giving us areas. They're giving us the actual sides in the figure. So they want us to compare these two parallelograms. Okay, so we're gonna, you always kind of start with whatever figure's on the left. So, oh, quiet phone. I get a spam call about 10 every day. It's really annoying. Okay, so we're gonna compare the bigger figure to the smaller figure. And this is my ratio of the sides, the scale factor. But what do I have to do to that ratio before I put the answer in? What do I have to do to that? 21 over 15. Is that suspicious? Does it maybe simplify? I'm saying that kind of weird. You guys should be saying, yes, it does simplify. We can divide by 3. Yeah, very good, Vivi. So if you have a scale factor that can be divided, you do that and you divide it. So this one can be divided by 3. Okay, and if you're ever not sure, just test it, or you can go to our friend Desmos and give it a try and just type it in and it'll simplify it for you. So 7 over 5. That's our scale factor. That's how the sides compare. 7 over 5. Check, answer. Boom, correct. Yeah. Okay, and then the perimeters, it's going to be the same. So even if I added up the perimeters of the first parallelogram and then the second parallelogram and compared them, they would simplify down to 7 over 5. And those are the same way. Okay, now they want the ratio of the areas. So if we want to see how the areas compare, what do I have to do to this? Because areas are square centimeters. So what am I going to have to do to this scale factor? And the other one we square rooted, but we're not working backwards this time, so we just have to, what? What do I do? Here's your hint. Here's your hint right here. Bam. Bam. What am I going to do to these numbers? Starts with S, rhymes with raret. Yeah, very good. We're going to square it. Yes, we're going to square it. So we're going to go 7 squared and 5 squared. So our ratio of the areas would be 49 over 25. So if you have the areas, you square root to get down to the square root. The scale factor, no problem. And then if you have the scale factor, you square it to get that one there. Cool. Okay, the pair to the right are similar. The area of one figure is given. Find the area of the other figure to the nearest whole number. So this one, we're going to need to set up a proportion in order to solve it. Okay, so you can use a scale factor and then one of the pieces of information to solve for the other one. So that's like saying if we know the area of the small parallelogram, we can use a proportion to find the area of the big parallelogram. But first, we have to find a scale factor. What do you guys think my scale factor would be here? If I compared this one side length to the other side length, what would that scale factor be? Yeah, it's going to be 3 over 12. Can I reduce that at all? Say yes, say yes. Yes, you sure can. What does that reduce to? 1/4. Very good. So 1 foot compares to every 4 feet in the big one. No problem. So now we want to use this ratio to get the area of the other figure. But what do I have to do to this ratio first if I want to be able to compare it to the small area? Oh, we know the small area. And if I want to find the big area, what do I have to do to that scale factor first before I can do that? What do you do with all areas? Same thing we did last section. Oh, my cat's so weird. He's like flopped right on top of my girl cat and licking her face. They're so funny. Right after he drank from the toilet. I'm sorry, Princess Peach. Yeah, it's so gross. Okay, so what do I have to do to that scale factor? Same thing, it starts with the S, rhymes with rare it. Square it, I'm gonna square it, that's right. So we're gonna square, so anytime you want to take a scale factor and use it to find area, you have to square it. Then we can solve. Do you guys remember how to solve a proportion for the missing variable? What's that word or that method? Some type of multiplication. Starts with a C, rhymes with os. I'm very bad with my rhyming words today. Not cost, no. Some type of multiplication, cross. Yeah, very good. Cross multiplication. So we're going to multiply what's across from each other. Now, this is something I believe that we talked about when school was, we were maps testing and it came, so we didn't talk about it a whole lot, but it's in Moodle, it's there. And if you need my help with it, you let me know and we'll set some time and go through it. But you multiply what's across from each other and divide by what's left over. So we're gonna go 16 times 9 and divide by 1. What's 16 times 9? And then you divide by 1 technically, but you really don't have to do that. What's 16 times 9? 147. Yeah, so the area, oh, don't tell me it's that. You guys. Okay, so what's 16 times 9? I don't know what it is. I'm going to use my calculator. 144. 144. Hey, you were close. 144. So that would be the area of the larger parallelogram. And that's kind of the idea for the rest of the assignment, is it's a whole bunch of knowing when to square and when to square root. That's it. You're just comparing things. And if it's anything with area, if you want to use it with the area, you gotta square it first. So, does that make sense, guys? We went a little over when I said we would, but yeah. All right, if you're still struggling, let me know and I will help you. So just if you know you're gonna struggle and you wanna set some time, let me know. I will fit you in. It's all good. So, okay. Let's talk about this week now. I have some fun, interesting pie facts. You guys need to go grab a snack super fast? People who are listening to the explanation, do you need a quick snack? Or are you good? I want to be understanding. Okay, go grab a snack super fast. I will pause my recording here because you're going to want to take some. So yeah. Okay, so first question is we are going to be asked to find the circumference of circles. What is the circumference? Do you guys know? There's a really cool book called Circumference and the Dragons of Pi. It's really cool. I think I'm going to have to get it and read it. I think I'm going to do that for advisement. Oh my gosh, I'm totally going to do that. Probably. It's a very, yeah. Circumference. And the Dragon of Pi. Yes. I'm buying this. Add to cart. It's happening. Boom. Okay. But anyway, what is the what does circumference mean? So if we have a circle, where's my mouse? Where did it go? There it is. So we have a circle. We want a more circular circle. And in this circle, they're telling me the circle has a diameter of 10. What's the diameter? Okay. What's the diameter? What does that mean? I'm gonna let my daughter play with my phone.
The line that separates it, kind of?
Yeah, it totally is. It splits your circle in half, and it goes right through the middle. Yeah, the dot in the middle to the side. Yeah, and it's got to go the whole way through. So the diameter goes through the entire circle. Okay, that is a diameter. Where is my pen? There it is. So that is the diameter.
And the radius is half of that?
Right, very good. Radius goes from the middle to the side. That's half of that. What is circumference now? If they want the circumference of the following circle, we're not talking area, that's different. What is circumference? It's like the perimeter. Yeah, very good. Circumference is the distance around a circle. Good. So there's two different formulas you could use for circumference. You can use 2 pi r, and that's the formula you would use if you're given a radius. But if you're given a diameter, you want to just do diameter times pi. And you're going to be asked to do two types of answers. They're going to want an exact answer and an estimated answer. It could be confusing because sometimes people think exact answer, I don't know, I always think decimals and I don't know why, but technically that's not the exact answer, that's a rounded answer. So for your exact answer, we would take the formula. I always write the formula first. It really helps because all we're doing is just replacing those variables with the number. So we're not going to replace pi with 3.14. They might tell you to do that in Math Excel, and if that's what they tell you to do, go for it. But Most often we just use the pi key on the calculator. So we bring down circumference. Our diameter was 10, so we replace that d with a 10 and then leave the pi there. So for your exact answer, it would say 10 pi. This is your exact answer because pi cannot be rounded. If you wanted your estimated answer and it says rounded to 2 decimal points, this is where we would go into Desmos and where we would use the calculator there. So I'm going to go to desmos.com/scientific and I'm going to type in 10 times pi. And then it shows the answer right there, 31.415. And since I want 2 decimal places, what would I round that to? What would that round to if I want it to 2 decimal places? To anybody. Anybody out there, what would I round that to? Hello, hello, hello. You're really close there, Mr. Parker, but would I keep it at 31.41? No, I want to. He's right about the number of decimal places.
31.42.
Very good. Yeah, I would keep it at 31.42. No, that's okay. That's why.
The 5 rounds to 2 on the hundreds spot.
That's right. Very good. The 5 bumps it up to a 2. That's why we talk about it, because everybody could do with a rounding review. Hey, I understand. I get it. Coffee is amazing. All right, so next one. The next one, we are given a radius. So we're going to use a slightly different formula. We're going to go to, ooh, that sounds good, times the radius times pi. And they're saying the radius is 8. So I'm going to replace the r with 8. And then now I need to give my exact answer. How much pi would I have here for my exact answer? What do you guys think? What would I just leave it at? No, it's not 2.8, and that's a really good thing to talk about. These look like decimal points. They're actually multiplication symbols, because now that we're getting into algebra, and it's actually better to use parentheses, so I will try and do that, because you're right, it is confusing. It looks like a decimal point, but that's a form of habit. Pardon me. So what would so for the exact answer, that's always in terms of pi. So the pi just kind of comes along for the ride there. But I can simplify this part. What does that simplify to be? Oh, that's okay. What does that simplify? What's 2 times 8? 16. Yeah, because remember, when stuff is right next to each other, like 2 and r, that means you're supposed to multiply. So my exact answer would be 16 pi. And then for my estimated answer, remember, that's where we go to Desmos. And it's kind of cool because all we have to do is replace that 10 with a 16. And we get 50 point what? What would that one round to? For 2 decimal places. What do you guys think? 50 points.
It'll be 2.7.
That's right, 50.27. The 5 bumps it up. If it was anything lower than that, it would just stay the same. So 50.27. Good. Last one. Okay. So what am I given here, guys? And I want lots of answers here because it just goes so much quicker when that happens. What do I have here? Do I have a radius or a diameter? What do you guys think? Is that a
What?
radius?
That's a diameter.
Diameter. How do you know that's a diameter?
So it goes all the way across.
Very good. So it is a diameter. Hello. It is a diameter. It goes all the way across the circle. So we're going to use the diameter formula. Pi times diameter. So what would my exact answer be? How many pi's? If I replace that diameter with the diameter I'm given, how many pi's would I have? What do you guys think?
What do you mean? Like one?
Well, so what we do, the whole process, what we've kind of been doing is you have the formula, and then we replace that variable, that diameter, with the actual diameter. And we replace the radius with the actual radius. So basically, I'm just saying, what do we get? What's our diameter? What am I going to replace it with? What diameter was I given in the problem? And Vivi, thank you for asking a clarifying question. That's really good. Good job. So what diameter did they tell me? What's our diameter? What's
18.
Our 18? Yeah, that's our distance across the whole circle. 18 pi.
Oh, I see. Okay.
Yeah, no,
I just don't think of it as how many pi's there are.
Right. Nope, you're right. It's just kind of weird to think of it that way. Yeah, I said it weird. Sorry. So that's my exact answer. Now I want to get my rounded answer. So I'm going to go to Desmos. What do you guys get? What do you think? Go to Desmos. Let's do it to it.
Oh God, I accidentally muted myself. I accidentally muted you. Hold on.
Oh, that happens. So we have it in there, guys. What would I round it to?
What, like, oh, I mean, I could let someone else do this one if you want, but
hey, it's all good.
It's just 56.55.
Yeah, very good. 56. No, that's okay.
You just, if it's over, if it's 5 or over, you just put another number on it.
Yep. So we want. That's really good to clarify, and I'm glad that you're asking that. So let's say we have our decimal here, 56.548667776. So we want, they'll say round, what number? I love that you're asking right now. That's awesome. Keep it up. Yeah, that's the best way to learn it, is to ask questions. So what number? Parker. Use guys, I tell you. So they, 18. Okay. Yeah, no. Good question. So the 18 is our, hold on, I have like 4,000 things open on my computer. There we go. So the 18, so what we have to do when you guys are doing this is you're given a formula okay? And you have to pull in the information from the formula. So for circumference, you can either use 2 pi times the radius or diameter times pi. You can use either one. And I'm saying it makes more sense to use the diameter times pi formula when you're given a diameter, and we knew it was a diameter because Vivi says it went across the whole circle, and you're going to use the 2 pi times radius formula when you have a radius. So it just depends. If they give you a radius, use this formula. If they give you a diameter, use this formula. And that 18, that's our diameter. That's where that came into place. So all you do for the formula, to find the circumference, you replace the diameter with the diameter that they gave you, which was 18. Good question. Then that is our exact answer. All you have to do is replace the diameter with the diameter they gave you. Then we put it in Desmos, and they want it rounded to 2 decimal places. So that means 2 numbers after the decimal point. So you go to that second number after the decimal. Okay, so this is the last spot that you want. And then you look to the number after it, and if that number is 5 or bigger, you bump that number up 1. If it's smaller than 5, then you leave it the same. So we had an 8, so we bumped it up to 5. Good question. And I'm happy to go through that further. We can just meet and go through it and get it done. All right. I have too many things open on my screen, guys. I do. So now that I've confused you with circumference, no, I'm just kidding. Now that we're done with that, let's talk about area. We got to find the area, guys. So area is kind of cool. There's only one formula. Only one formula for area. Only one formula here, okay? Anybody know the area formula? Area. Yeah, very good, Vivi. Very good. It's the pi, okay, times the radius squared. So there's only one. You have to have a radius, okay? So there's one formula for the whole thing. Super nice. And your answers will always be in like square centimeters, square inches. No, you're not. And I can vouch for that. I've seen your scores and stuff. No way, man. That's what you do if you're unsure of something. The best thing you can do to advance yourself in math is to ask questions about everything. Everything. That is such a strong skill to have. It's asking questions. I guarantee you that is how I became a math teacher, just because I ask an annoying amount of questions. I am so annoyed with bills, with figuring out insurance. Oh my gosh. When I was doing my taxes, should have seen how many questions I asked. But that's what you do. That's how you do it. Good job. So keep it up, my friend. I love it. Okay, so we want to find the area of the circles. We want, again, an exact answer and an estimated answer. So first step is we're going to write the formula down. Okay, so pi r squared. R radius, what is R radius that they gave us? What is R radius that they said for number 1? We have a circle with a radius of what? 10 centimeters. Very good. Come on, guys. I know Vivian, Isaiah, and Parker, they're not the only ones here. Come on. Come on, friends. Everybody. Tynan and Jackson and Kira and Braylee and Luke and May. All you guys. And remember, if you're not sure and if you're feeling kind of weird about it, you can always private message me. If you want to answer, but you don't want everybody to see for some reason, even though we're all totally cool about that, send me a private message. So that's it. It's how I know that you're here and that you're paying attention. It really helps. Thank you. Thank you. Okay. Anyway, so Isaiah, you got it, my friend. Our radius is 10. So we're going to replace the R with 10. Okay? So that's our second step. First step, write the formula down. Second step, replace the variable with what we're given. Third step is we're going to give our exact answer. So that means we're going to square the radius and stick a pi next to it. So what is 10 squared? What is it? Here's where I should see lots of people run into their calculators. I can't see that, but.
What, 100?
100.
Yeah.
You got it, my friend. 100. Very good. My cats are so stinking cute. Okay. 100. Yeah, oh, Kira, I knew you meant that. Very good. Thank you. So 10 squared is the same as 10 times 10. Some people confuse that with 10 times 2. And when your brain's tired and doing math a lot, that's easy to do that. But we have 100. So we're going to say 100 pi centimeters squared. That's our exact answer. Five to the 5th power, you mean? Like that? 5 squared is 25. Yep. Good clarifying question, Isaiah. Good job. Yes. And everybody confuses that. It is so common for people to say, oh, 10. No, not 10. So common. So this just tells you how many times to multiply that number. So 5 squared is the same as 5 times 5. 6 squared is the same as 6 times 6. Good questions, guys. Awesome. So our exact answer, now we want to get our rounded answer. So what do we do for the rounded answer? We round. I suppose I deserve that. That's logical. We round. We're going to go to Desmos. That's the Desmos cheer. Desmos. It's 10:41. Awesome. I am not sponsored. Okay. So we're going to go to 100 pi. Okay, now we're going to round that to 2 decimal places. What would that be, friends? What would that be? 314 point what? Yes, boom, Isaiah. No, I know what you meant. You put an extra decimal in there, but you rounded it correctly. You did. Very good. 314.16. Now I knew what you meant. That was good. Centimeters squared. Nice. That was nice. Good. Okay, let's look at number 2. Uh-oh. Problem. Number 2. Problem. What's the problem there? Do we have a radius? Because we're going to write our formula down. Pi. Do we have a radius there? Can I just put 18 in my problem? Better tell me. I'm going to do it. I'm going to write it. It's going to be wrong. I'm going to do it. And I'm going to cry. It's going to be wrong. No, I can't. Okay. Why not? Why can I not put 18 in there?
Well, you're trying to find area, aren't you?
Right. No diameter or no circumference.
Mm-hmm.
Yes. We want area, so we have to have a what?
Radius.
I have to have a radius, right? I cannot have a diameter, and I am given a diameter. That 18 is a diameter. So what would my radius be? Radius is this thing from the center to the side. So if the diameter is 18, what's the radius?
6.
Not 6. You're
Wait,
dividing by
9.
3.
Oh
9.
God.
Yes. No, that's
6
okay.
would
That's
be-
okay. That's good. You're answering. It's great. It's lovely. So we divide by 2. That gives us the radius of 9. So whenever you have a diameter sliced in half gives you the radius. Okay? So we're going to plug in a 9 in there. And now I'm ready to get my exact answer. Hey, yeah, Vivi, there you go.
Thank you. Yes, I always thought I was in the upside down, and you just convinced it. So I'm convinced me.
You're in the
So
upside. Oh no. No demogorgons. No. Okay. Those are terrifying, by the way. Anyway, okay. So we have our area. Now we're, oh yeah, demodogs are worse. So what do I do for the exact answer? What do I do there? Same thing we did here. You can look here for a little inspiration there. What am I going to do for that exact answer? So I have area equals pi times 9 squared. And 9
is that just the exact one?
Yeah, we just want the exact one for now.
But so that's it, isn't it?
Not quite yet. We got to do something with that 9 squared. What is 9 squared?
Oh.
It's the same as 9 times 9. And I love that you said that, Vivi, because that helps me see what everybody might be thinking. It's good.
81.
81. Yay. Good job, guys. 81. So my exact answer is 81 pi centimeters squared for my rounded. I'm going to go to Desmos. My cat just jumped when I said that.
He's so excited that you're sponsored by Desmos. That's why.
So excited. He just kind of like twitched. This is brought to you by Desmond. No, I'm just kidding. It isn't. But okay. So 254 point what? What would that round to? And I can erase that so you can actually see it. There we go. 254 point what?
47.
47. Yep, very good. Centimeters squared. Yeah, the reason it's 47 is, I'm glad that you said that, is because that 6, okay, that's where we want our last spot to, and the 9 next to it makes it bump up to a 7. Good. Good stuff, friends. Okay, so let's talk. So we did area and circumference. You guys are going to get questions like this for your homework. A pizzeria will bake and deliver a round pizza with an 8-inch diameter. So what I would do immediately is draw that sucker out. Here's our pizza. There's an 8-inch diameter. Is that a line across the whole pizza or half of the pizza?
Half.
If it's a diameter,
What?
the whole pizza, right? But Vivi, I might have confused you
I
because
thought
you're
it was
thinking.
like splitting it in half.
Yeah, I might have confused you because you're probably thinking slicing the pizza in half. Sorry, I should have clarified. So a diameter goes across the whole pizza. And this one has 8 inches. It's not very big, right? Doesn't seem very big. So we want to find the area, find the exact area. So no terms of pi, so they want us to round. Nope. See, I always confuse that. Exact area and an approximation. So they want both. Excuse me. I always confuse that. I always think decimals. Okay. So we want the area formula. So that's that pi times the radius squared. Radius, do I have a radius? I don't, I have a diameter. So what would my radius be?
Diameter divided by 2.
Very good. Yes, Vivi explaining it and Kira putting the answer. That was perfect. So we're going to put a 4 in there. And then what is 4 squared? 4 times 4?
16.
16. Very good. So my exact answer would be 16 pi inches squared. If I want the rounded one, I'm going to go to Desmos. I'm saying that all day. It's just so fun to say. Desmos for the win. This is not an ad. Desmos. Okay, so I'm going to replace that 81 with 16, and we get an area of 50 points. What would that be if I rounded that to 2 decimal places?
Is 6 goes up 1.
So 7. Good job. Good job, guys. Good job. No, you guys did good. Good job. I love seeing people put that up there. That makes my heart smile. Sorry, I wanted to say that as weird as possible. I think I succeeded. So yeah. Very good. Cool. So you'll have a lot of stuff about that. Oh, we got to talk about sector area. Okay, so you're going to have questions, I believe. I'm not going to go too in depth with area of, oh, that would be pretty cool. So you might be asked to find the area of the shaded sector of a circle. Now this one's pretty nice because you have a nice chunk cut out of it. Okay, it's cut out. No. Go back. Okay. So there's actually a formula for the area of a sector, okay? But we'll get to it in just a second. So let's think about the area of this circle here. Let's think about the area, okay? Area equals pi times that radius squared, okay? That's the area of a regular circle. And now this circle looks like an exact quarter of it was removed. So if I want to think about splitting this circle into quarters, what would I end up dividing my area by? When you split something into quarters, what do you divide by?
What, 4?
By 4, yeah. So if I find my area and split it into fourths, that's going to tell me the area of each little section. And then if I want the area of all 3 sections, we got to think about what we would multiply that by. So let's do it. Let's go pi times 16 squared divided by 4. And now we can type right into Desmos. So let's do it. So pi, I'm going to do a fraction first. Pi times 16 squared. And on the bottom, I split it into fourths. So what do I get? 201.06. So let's round it to 201.1. What do you guys think about that? 201.1? Okay, so that is the area of one of those quarters. What am I going to do to find the area of the shaded section? So 3 of those quarters. What do I do? Multiply by what? You're right, by 3. You got it. Good job. So if I multiplied by 3, that would tell me the final answer. Now let me give you the area of a sector formula. It's kind of nifty. For the area, oh, I can't do that. All right. You know what? I forgot my daughter stole my cell phone. I was going to look it up. Is it? Oh, my husband told me your cell phone's right next to you. Thanks, husband. Okay. So, area of a sector formula. For that, there's two ways we can do it. I'm just going to give you the one because I don't want to throw too much at you. But the actual formula is you take your angle, okay, that you're given. So we are given a 90-degree angle, and we compare it to 360 because a full circle is 360 degrees. Okay, so what is 90 over 360 simplify down to? Who thinks it's 1/4? It is. It's totally 1/4. Isn't that cool? It's 1/4.
That's 90, 180,
Yeah.
270. What the heck?
Whoa, who was that? That was impressive, but don't burp.
Sorry, that was Cade.
That was Cade?
Yes.
Oh, is Cade at your house?
No, I meant it's.
Hi, Cade. Cade's in my other class. Hi, Cade. That was gross, but impressive. I also share the ability to belch very loud. Yeah, Cade, my 8th grade student, is at telling my husband Isaiah's house, and he just burped super loud. It was pretty impressive, but kind of gross on a mic to do. Yeah. So, okay, my husband's like walking away, like whatever, Jen. Okay, so Isaiah's at Cade's house, right? Okay, cool. Awesome. I said that weird. Yeah, I explained it wrong. Okay. Anyway, so that is what you take, and then you're actually multiplying that 1/4 times pi r squared. So that's where they get that formula from. So think about it, try it, look it up on Google, all that good stuff. But if you need more, I know, I'm sorry. Then I will send it to you. But guys, you also have to do stuff with 3D figures. So I just want to throw that out. It's real simple. You're just identifying figures. It's a quick Moodle quiz. So make sure you use what's written on there. Okay? Okay, aren't they so cute, Troy? Okay, and there's lots of cool stuff on there. But you guys are free. That's all I have for you. Thank you for listening.